Hey everyone, and welcome. Today we are going to pull back the curtain on one of the coolest, most powerful features in the Go programming language. Its truly unique take on concurrency. Seriously, if you've ever found yourself fighting with threads, locks, and mutexes, you are going to love this.
So let's just ask the big question right up front. Why is this stuff so notoriously difficult? For decades, developers have been wrestling with this one core problem. How do you get different parts of a program to run at the same time without them stepping on each other's toes and totally scrambling your data? It's a real headache.
And that brings us to our first section, the concurrency challenge. You see, the classic problem is what we call a data race. It's this super risky situation where multiple functions are all trying to read and write to the same piece of memory at the exact same time. And when that happens, well, chaos is pretty much guaranteed.
Okay, so what if the whole way we've been thinking about this is, well, wrong? This is where Go comes in with a pretty radical idea. It's a whole new philosophy for getting things done concurrently.
And this slide just nails the difference. The old way, the one that causes all the headaches, is communicate by sharing memory. You know, you have a bunch of threads, they all need access to the same data, and you have to use all these complex locks to keep them crashing into each other. Go just flips that entire idea on its head. It says, share memory by communicating.
This right here, this is the mantra. It's the core philosophy of Go's entire approach to concurrency. Instead of having all your different functions fight over access to the same piece of data, you just pass the data between them. It's like a baton and a relay race. At any given moment, only one function actually owns the data. And if only one thing owns it at a time, data races just can't happen. It's brilliant.
You know, a really fantastic way to picture this is the classic Unix pipeline. Think about it. You have program A, it does its thing. You have program B, it does its own separate thing. They don't touch the same memory. Instead, program A sends its result through a pipe, and that output becomes the input for program B. The pipe itself, the communication, is what synchronizes everything. It's an old, elegant, and battle-tested idea.
So that brings us to the star of the show, the Go routine. This is Go's fundamental unit for doing work at the same time. And yeah, you heard that right. It's Go routine, not co-routine. A subtle but important distinction. So what exactly is a Go routine? Well, the definition is almost laughably simple. It's just a function that's running at the same time as other functions. That's it. That's the whole thing. It's an incredibly simple name for an unbelievably powerful concept.
Okay, but what's the big deal? Why are they so special? Well, unlike old-school operating system threads, Go routines are ridiculously lightweight. They're so cheap to create you can spin up thousands, even millions of them, without breaking a sweat. They're also multiplexed, which is a fancy way of saying if one Go routine gets stuck waiting on something, like a network call, the others can just keep on working. And maybe the best part? The Go runtime handles all the complicated scheduling stuff for you. It just works.
All right, now for the fun part. Putting Go routines to work. Now, with all this power, you'd think it has to be super complicated to actually use, right? Nope. Turns out the secret to all of this concurrency magic is just one little word.
This is it. That's the secret sauce. The keyword Go. This one tiny two-letter word is what unlocks everything we've been talking about.
And here's what that looks like in real life. You take basically any function, in this case we're sorting a list, and you just put the word Go right in front of it. Boom, you're done. You've just told Go, hey, run this sort function, but don't wait for it to finish. Start it up and immediately move on to the next line of code. For anyone who's used a Unix shell, it's a lot like putting an ampersand at the end of a command to run it in the background. It's that easy.
But hold on. This seems almost too easy, doesn't it? And that incredible simplicity actually points to a problem. Right now, we've started a conversation, but it's only going one way.
And the original documentation for Go puts it perfectly. We've told our Go routine to go off and sort a list in the background, which is great, but we have absolutely no way of knowing when it's finished. It can't tell us it's done. It can't give us the sorted list back. When it's finished, the Go routine just disappears, silently.
Which, of course, leads us to the most critical question of all. We figured out how to send work out into this concurrent world. But for any of this to be useful, we need a way for that work to report back. So, how do they talk back? Answering that question is what takes us to the entire other half of Go's amazing concurrency story.